Okay. 5.9, ask you to find the tension on the three cables that are there. They give the weight as W. So you're really not solving for a specific numerical answer. You're solving for an answer as a coefficient. Okay. I'm going to start with the easiest one just because I am. You can see we're going to do part A first. And for part A, you can see that the easiest one to solve for, start with, is going to be cable C, the tension of C. Well, it has to hold up the entire thing and it's at equilibrium, so the tension of that one has to be W. Okay, that's going to be easy for us to start. And the other two have to hold it up. And you can see that in this case, the horizontal tension of each of the cables, A and B, have to be equal. So T X A has to equal T X B. That just has to be so, otherwise it would shift from side to side or accelerate from left to right. And that T Y A plus T Y B has to equal the weight. I could have said T sub C because it really technically holds up cable C, but since we know that it's going to hold up the weight of the little light there, they have to be equal. So those two relationships are necessary conditions for equilibrium, for it to stay in one spot. So in order to make that happen, it's going to be easier. And we're just going to use trig for those two things. The angles are easy ones. You can see the angle on the of cable A is 30 degrees to the horizontal, and the angle of, let me mark it, okay, 30 degrees to the horizontal. Come on. Okay, and for angle B, it's 45 degrees to the horizontal. So again, those aren't going to be terrible angles to work with. We know what all those are pretty much. So, and again, you're going to be tempted to write things like root 2 over 2 and root 3 over 2, and you're going to want to work with those. I mean, you can, but when you get to the end answer, it's going to, that you're going to want them to be decimals because you're going to be dividing one by the other, and you have to carry terms around. You really want your answers like that. The AP test can be forgiving about that, but it's not always, so you want to make sure that your answers are decimals because in the end, that's what they're going to be looking for. So let's start with the left-hand condition, this one here, and let's set it up. So that means that T cosine of 30 has to equal T cosine of 45. I'm going to bring that over here just to make it easier. Or this is A and B. Because remember, they're not the same cable, so that they don't have to have the same tension. So that means that cosine of 30 is root 3 over 2, so it's going to be 0.866 TA. Okay. Cosine of 45 is going to be root 2 over 2, or 0.707. So it's going to be 0.707 TB. Okay. Then I'm going to play games with this guy over here. Next, the right-hand condition, the vertical condition for equilibrium. And that's going to be, move this guy over slightly. Actually, I'm just going to put it down here a little bit, just to make it clear, maybe. Okay, so move it down this way. And that's going to be TA sine of 30 degrees plus TB sine of 45 degrees equals W. Okay. And again, we're going to be able to play the exact same game with those. We're going to say 0.5, because that's sine of 30, TA, plus, again, 0.707 TB equals W. Well, You can see we have two equations and two unknowns. So we can work with this though. I mean, two equations, two unknowns is good, right? I mean, neither one of them is solvable on its own, but we can easily substitute one into the other or play other games too. Like actually, we can actually subtract the two equations apart, people like that. Or actually, I think the easiest way to do it is to take this and substitute it wholesale into the other. Since 0.707b equals 0.866ta, we can actually just substitute that completely into here and solve that over. Okay. So then I'm going to replace this and say 0.5ta plus 0.866ta equals w. That's going to give me, I add those two together, 0.5 plus 0.866 just to make sure. That can't be right. Plus 0.866. 1.366. 1.366 TA equals W. Divide both sides, I get that TA is going to equal 0.732 W. And TB, remember, is just going to be this relationship over here. So I can say 0.866 times 0.732, whoops, 0.732 W equals 0.707 TB. So I just take 0.732 times 0.866 and I divide it by 0.707 again. And I get 0.897 7 W equals TB. And again, let's take a look at the cable itself and see if we like that. Okay. When you have two cables that are hanging, usually the one that's closest to vertical, the one you can see on the right here, this guy here, is going to hold up more. They're going to hold up a greater percentage of the weight than the cable on the left. And that's what happens. You can see it's 0.897 for that one versus the 0.732 for that one. So you can see you get different answers. You get a smaller answer for the one that's slightly off center. And it should work that way most every time you have two cables set up like that. Part B is a similar kind of problem. You can see we have the same kind of angles. We have a 45-degree here. But you can already see the problem. This one is actually lower. So what it means is that this one is going to have a weight that's going to be way bigger than one because it has to do two things. It has to support both the lamp itself and it has to support this guy here. So it's going to be way bigger than that. So it's going to take a little bit more effort on our part to actually work this problem. So it's going to take a little. So erase these so we can see the numbers a little better. But I just want to make clear that it's going to take a little bit more to actually do this than we did last time. But the principle is solid. We're going to balance the equilibrium of each side, and then we're going to figure out then we're going to set the equations, and we're going to set them equal. We're going to put two equations just like last time, and we're going to set them equal to each other. So let's try that. First, let's start with the easy one, because let's just say it so we can get it done with. T sub C is going to be the weight. We got that done. We won. So the next one we're going to do is just set up A and B. And we're going to balance the horizontal forces the same way, it turns out. Okay. But you can see the angle for A is a little bit different because it's measured with the vertical. So when we find the x component, it's not going to be the cosine this time, it's going to be the sine. So it's going to be T sub A. And we're going to say sine of 60 equals T sub B cosine of 45 degrees. Okay, this is the axis. Good. Okay, and we're going to add up the y's also. I'm going to put these like this. When we add up the y's, the difference now is that the only one that's upward is the T sub B. So T sub B, and again, it's the sine of 45. Of course, it doesn't really matter because it's 45 degrees. We'll get the same value either way. But it's going to equal both the downward pull, which is going to be T sub A, and remember it's going to be this component over here. So it's going to be the cosine of 60 degrees plus the weight. So these are going to solve out a little differently than last time. So this guy over here, the one up here, is going to simplify pretty nicely. The sine 60 is the cosine of 30. So what we're going to get for that is going to be, I'm going to put it up here, it's just going to be 0.866 T sub A equals 0.707 T sub B. Really, I think that's what we had last time also. But you can see that the f sub y equation is going to be different, or slightly different anyway. 0.707 T sub B equals 0.5 T sub A plus W. Okay. Now if you look, you can see we can make the exact same substitution we made last time. I guess in many ways it's the same. I'm going to take this whole equation here, and I'm going to substitute it wholesale into here. So I can take one term out. Again, you can do, there's all kinds of ways to do this, and you know what they all are. So, so I'm going to just replace it here. So I'm going to say 0.866 TA equals 0.5 TA plus W. Okay. Subtract it from both sides. I'm going to get it looks like 366, but I'm still checking it. I don't believe in myself. Okay. 0.366 TA. That means that TA is going to be 2.73 W. And I predicted that I didn't make any prediction about TA. I said it was going to be, I didn't say anything about it actually. Okay, but we can now find out what TB is going to be. I said TB would be a lot bigger, and let's find out if it is. So over here we said that 0.866, 2.73 TA equals 0.707 TB. Oops, sorry, I made a mistake here. This shouldn't be that. It should be weight. Okay, so I'm going to multiply those together. 0.707. I got 3.34. Oh, I found another dumb mistake. This one here should be a 6, not an 8. Okay. And I got 3.34. So I got TB equals 3.34 weight. Good. All right. And you can see again that I predicted earlier that the force, the tension on the cable, the short cable that was actually above the light, was going to be that was the one attached to the ceiling was going to have a lot higher tension than all the others, or a lot greater force, and it did. I didn't necessarily expect that cable A was going to have such a high tension, but it makes sense. It had to balance out the really high tension of cable B, so it needed to have a high tension in order to do that.